past few weeks have been pretty insane as far as development goes, and you can probably tell by the state of my desk. But what have I been working on? Well, I'm pleased to say that we finally reached the beta stage. Everything is completely finalized and parts are starting to be ordered and pre-orders are going out to people. I've selected 100 different community members from the project Discord of varying skill levels and use cases, anyone from programmers with 20 years experience with hardware and C++ to people who have never even programmed in their life. Why? Because I want to get an idea of how each person may approach this kit differently and determine how I can best cater to people of any skill level who are interested in getting into hobbyist computing, hardware design, and programming. I'm really grateful for the community that has formed around the PocketMage, and I'm especially thankful for those who have willingly elected to pay the beta's higher price compared to the final model and help me raise funds for injection molds. Through the beta, I hope to get many of the issues with the hardware and code ironed out before a full production, and I look forward to getting feedback from other enthusiasts on how my product can be improved. Let me clean up the desk here. Anyway, what's this video going to be about? Well, there was a lot of polishing, research, and design work that went into taking this project from 90% to 99%. And I say 99% because this isn't quite the final release, it's still the beta, so there are a couple hiccups along the way. Before we get started with that, let's hear a word from the sponsor of today's video, JLCPCB. JLCPCB has been there since the beginning of this project, providing me with fast, high quality, and cost-effective prototype circuit boards. They've enabled me to iterate on my designs and create the device that you see today. They're super easy to use, even for hobbyists, and I've found them very reliable at delivering working PCBs since I started ordering from them. The ordering process is super easy. You just upload your PCB Gerber file, select your board settings, and you get a quote almost instantly. Setting up PCB assembly is just a couple more clicks after that. Their boards are also affordable and fast. They have 1 to 8 layer PCBs that start at $2, and production happens in just 24 hours because of their large-scale production facilities. I've been using JLC for years, and I can honestly recommend them to anyone in need of some custom boards. Right now they're running a deal where you can get $30 off your order and high-quality 6-layer PCBs for $5 with no extra engineering fees for their 2 micro-inch NIG finish. Click my link in the description to learn more, and thank you for listening to the sponsor segment. Let's get back to the video. Let's start with that final batch of PCBs that JLC sent over. I know I mentioned in the last video that the device was done, but in my defense it was done in a way. The hardware features have changed very little since the V3 video, only polishing what was there already and implementing some final features that will benefit the device in the real world. Okay, so this is the V2 PCB and this is the V3 PCB. To start, the shape has changed slightly to accommodate these 3 new screws below the keyboard. This was because I was moving to an injection molding friendly design for the beta and I needed to get rid of these side-facing screws right here to save money on the molds. More on that later. Furthermore, on the physical side, I've added a small notch on the top of the PCB to allow the cable for the OLED a little more slack so that it doesn't get damaged from being cramped against the inner wall of the case. This is one of those things where I wanted to try and fix something before it broke, even if I haven't seen that particular failure case yet. The power system has also gotten somewhat of a refresh in this version, without going into too much detail, because this could fill an entire 10-minute video, and my girlfriend knows this because she listened to it a couple weeks ago. Basically, the old V3 boards use a sort of dumb Type-C communication that use simple resistors on the communication pins of the Type-C connector to tell the charger to provide exactly 5 volts at 500 milliamps max. This was okay for a simpler device operation scheme, but I realized it would be nice to have a faster charging and be able to plug devices like keyboards into the USB-C port with one of these guys, USB-C to USB-A. So I opted for a power system overhaul. This overhaul included an all-in-one battery management and power system. This was done with an IC that charges and discharges the battery, handles load sharing between the charger and the battery so that you can charge and use the device at once. And as I mentioned, this chip allows for reverse boost from the battery's 3.7 volts to the 5 volts required for that USB-C. And this will allow powering of USB devices from the PocketMage, and the chip also negotiates fast charging via the built-in communication interface there. All in all, this is a huge facelift for the power system, and this was much needed before the PocketMage went into production. On the topic of power, while I was working on sourcing components for the kits, I had a very difficult time sourcing one of the cell phone style batteries for the PocketMage. This is one of those cell phone style batteries that was used in V3. I ended up going with a more standard and cheaper pouch style battery. It has a pretty simple JST connector. Let me pull that out here. The battery has a very simple JST style connector that just plugs in down there, and the case has also been updated to reflect this change. And finally, my favorite little change on this PCB is the adorable dip switch right here that hides under the battery. If you're not familiar, a dip switch is a kind of like a small switch that is put onto PCBs to allow hardware changes to be made on the fly. The particular switch that I've added is actually a bank of 2 different switches. So one of them controls muting of the built-in buzzer, and the other controls putting the device into programming mode. Since the communication on the USB port is shared between the ESP32 and the charging IC, there needs to be a switch that swaps control of the USB port between the ESP and the charger. Normally, we want control to go to the charging IC, so that we can negotiate fast charging with the charging cable that it's connected to. But in programming mode, we want to switch control to the ESP. We want to do that so that we can program it over the USB port. The dip switch controls this switching using a multiplexer on the board, and it switches the data lines from the USB from the ESP32 to the charger and vice versa. I've also changed it so that to get the actual ESP32 into bootloader mode, you simply have to hold the power button while plugging the device in, and the power button is here. So you hold this and then plug it in. This is much better than what I had to do before, which was short these tiny little surface pads while trying to plug in the device at the same time. There were a couple issues with the new beta PCBs, but luckily they could be fixed by simply desoldering components on the PCB. The first issue was simply that the fuse here was wired incorrectly and essentially was shorting the 5 volts from the USB port to ground. Side note, and not related at all, thank you ASUS for making motherboards that don't fry when you short power and ground on the USB ports. Anyway, this issue is easily fixed by moving the fuse to the right spot, and that will be done on the beta PCBs. The second issue had to do with the capacitor taking too long to charge up and preventing the ESP32's boot select pin from being pulled high fast enough and causing the board to be permanently in bootloader mode when plugged in. Again, this is convoluted but easily fixed by removing the capacitor, and it wasn't critical because the capacitor was only being used for hardware debounce, which can be done in software if needed down the line. So far, no issues after removing that cap. Now let's get into the cases. As I touched on briefly earlier in the video, I plan to use injection molding for the larger production volumes of the final production, but for the beta run, I will be doing 100% of the production on the Form 4 that Formlabs generally sent over to me a few months ago. I can honestly say that this printer has been an asset in the production and development of this device. The prototyping process would have been significantly longer or not possible altogether without this printer, so huge shout out to Formlabs for that. Because I want to injection mold the final production parts, I wanted to prototype the injection molded parts and use them for the beta. This meant a full redesign of the cases to better suit injection molding over additive manufacturing. The good news is, I found out that the Form 4 is excellent at producing parts that are intended for injection molding, so I've had no issues with compatibility there. If you're not familiar with the injection molding process, that's okay, because neither was I when I started this. Essentially, design for injection molding boils down to 3 simple rules. Rule 1, draft everything. Every face that would normally be perpendicular to the pull of the mold needs to be slightly angled so that the part won't get stuck in the mold. For example, if you have a cube that you wanted to injection mold, the sides perpendicular to the mold would need to be angled out by a few degrees to ensure proper ejection. Rule 2, no overhangs unless you want to empty your entire savings account. This one is pretty simple. If you have undercuts or overhangs in your parts, the molds need to have multiple actions and pieces to be able to form the part correctly. For context, an undercut is any geometry that will prevent the part from being ejected from the mold because it creates material in the way of removing the part from the mold. A good example of this is on these old cases from the V3 video. You can see this slot right here would be an overhang because if we mold the part this way and plastic is formed around a piece that goes in here, the part won't be able to be removed because this piece will be holding it in. And the third rule is make everything a shell. This is a pretty simple one too. You can notice these parts are all kind of a thin assembly. This injection molding process doesn't like thick volumes because the molten plastic tends to cool unevenly in a big volume and causes warping and shrinkage in the final part, which we don't want if we want good tolerances and fits. So again, these parts are thin with ribs for structural rigidity, these parts as well. With these 3 simple rules in mind, I took to the task of remodeling each of the case parts to make them injection molding friendly. Everything was a thin shell, and I used thin ribs for support, just like real plastic products. Oh yeah, and by the way, you'll never be able to unsee that draft angle thing. Like, go look at any injection molding plastic part in a product. You won't find any true 90-degree angles. Like right here, this tape dispenser, these faces are slightly angled. It was obviously in the mold this way. Or even something like this little adapter. These faces are slightly angled this way and this way. And then on the other side the other way, because this part was molded this way. So just an interesting thing that you'll notice now. So obviously I had to throw those new design parts on the printer and get them in my hands. The parts turned out really nice in general. They look really slick with that ribbing, and they do really have that polished end user feel now, especially with those ribs and the really nice clear finish. The Form 4 also knocked them out of the park and required minimal supports to print these. So as a bonus, the thin parts are even less resin than the other ones, so good for production as well. As you can see from the table here, this was not a one and done process. Each of the parts had to go through multiple revisions before the fit and finish was up to snuff for an end user. I'll quickly go over the revisions for each part, starting with the main case. This here is the first main case that I made. This immediately did not work because this cutout here was a little bit too thin, preventing the PCB from laying flat on the case because of the battery connector. A little bit of a bummer, but I was able to get one printed out in about 4 hours on the Form 4. And that worked a lot better. This second revision has a much wider slot for the connector, allowing the board to be seated properly in the case. There was one other thing that needed to be fixed in the second case that it could only be noticed once the PCB was seated properly, and that was that the nuts that are glued in here, they just stuck up a little bit too high past kind of their seated position and caused a small gap in the case. So I dropped those holes down a bit, and now the bottom case is ready to go. And there is a third revision that actually hasn't been produced yet because I decided that it was kind of annoying to have to glue these in general. So I kind of made them go through to the other side like the other ones. It was a bit harder because of the position of them and the fact that they're on an edge, but I was able to punch those holes all the way through and make it so that you insert the bolts and the nuts in the same way as the other ones. So that was not too bad. For the top case, there was an initial issue with the first revision that made the top a little too floppy and prone to deformation when screwed in tightly. And this top bar here on the bottom revision, I added a little bit more support so that hopefully it wouldn't have as much flex, and it did turn out a lot better. After one revision, this part really was ready to go. The final piece, this lid piece here, had an initial tolerancing issue which made the hinge way too tight in this part of the case, and ended up in a fracture. And this is completely my fault because when I went back and checked the CAD, there was actually zero tolerance, which is not what you want. So one generation later, and we had the proper tolerances and we were working well, no fractures. This case is also very stiff for how thin it is. But I had some issues with the ribbon cable kind of flexing and kinking in like the folded position. It would kind of bend in on itself and create a sharp bend, which is not good for the ribbon cable. So I did add a geometry to this part of the case, and also the top part of the case here. If you can see that, there's like a guide that makes sure that that ribbon cable stays where it needs to be. And next is the battery door. This initial battery door had issues where it was a bit too thin and it caused fracturing and cracking. This is actually, there's a second one that was printed around the same time. So this is actually the first one that had flexing issues. It was a little too bendy, so I added these ribs on the sides here, and that helped a bit, but this one actually did fracture, and then the little compliant mechanism, clicky battery door, kept snapping off. So I decided to just go with a screw-in battery cover. This one is not the screw-in version, but it is thicker. You can see it even sticks a little bit past the bottom of the case, and that's because for 3D printed, it is a little bit more flexible than like an ABS injection molded plastic case would be. So I do have to make it a little bit thicker. I think I'll be able to keep it this thin in the injection molded parts just because it's got a bit more strength. But for this version, it's just going to be slightly thicker, which is not a huge deal. So those are just a few of the more interesting things that went into getting this beta off the ground and ready to ship. I've also been doing a lot of sourcing and testing of sourced parts and some programming here and there as well. So stay tuned for future videos where I plan to show my process for producing these kits, ordering parts, putting everything together, and shipping them out. I plan to do some cool stuff with fixturing to make production a bit easier on myself, so look out for that in upcoming videos as well. Thank you so much for watching, and a special thanks to my supporters over on Patreon for supporting the project. As always, have a good day.